Good morning to all. Today we shall discuss homogeneous differential equation. What is homogeneous differential equation? Previous classes we already discussed about the variable separation, also linear differential equation. Today we shall discuss about the homogeneous differential equation. First, in which way we can identify that it is a homogeneous differential equation. A differential equation of the form m of xy dx plus n of xy dy equals to 0, or f of xy dx plus g of xy dy equals to 0 is said to be homogeneous differential equation, is said to be homogeneous differential equation if f of xy and g of xy are homogeneous function of same degree. That is important. Which equation is said to be a homogeneous differential equation? If the differential equation is this form, then we can identify whether it is homogeneous or not. Then we have to check whether the function f of xy dx plus g of xy dy are homogeneous. Then f of xy and g of xy are homogeneous function of same degree. What do you mean by homogeneous function? For example, suppose the function is f of xy is equal to s square plus xy plus y square. This is a homogeneous function because its each term is a same degree term and there is no constant term here. So it is a homogeneous function of degree 2. It is a homogeneous function of degree 2. Similarly, suppose the function is g of xy equals to s square plus y square. It is also a homogeneous function of degree 2. So, if f of xy and g of xy are homogeneous function of same degree, then the differential equation is said to be homogeneous differential equation. For example, suppose the function is f of xy is s square plus y square plus 1. This is not a homogeneous function because this term is a constant term. So it is not a homogeneous function. So homogeneous function of same degree, then the differential equation is said to be homogeneous differential equation. For example, suppose the differential equation is of the form s square plus y square into dx minus 2xy dy equals to 0. This equation cannot be solved by variable separation. This is not a linear differential equation because each variable x and y of degree 2. So it is not a linear. It is also not Bernoulli's equation. Then we have to check whether it is homogeneous. Here the function f of xy is s square plus y square. Here f of xy is s square plus y square. And g of xy is minus 2xy. Both are homogeneous function of degree 2. So it is a homogeneous differential equation. The homogeneous differential equation means the functions with dx and the function which multiply with dy are homogeneous function of same degree. Means it's also degree 2, it is also a 2-degree homogeneous function. So this equation is a homogeneous differential equation. First you have to identify in proper way which type of differential equation is it. Then in this way we can solve the differential equation. This is a homogeneous differential equation. Then how we can solve it? Then we have to solve the differential equation in which manner? First we have to find dy by dx. dy by dx is here s square plus y square by 2xy. First we have to identify that it is a homogeneous differential equation. Then you have to find dy by dx. Then you put y equals to vx. Always for homogeneous differential equation you have to put y is equal to vx. Then dy by dx equals to, by product rule, v derivative of x is 1 plus x derivative of v is dv by dx. Instead of dy by dx we have to write v plus x into dv by dx. So this differential equation becomes v plus x into dv by dx equals to s square. Instead of y square we can write v square s square by 2x into vx. You have to first put y is equal to vx, then you find dy by dx. Then the equation 1 becomes a v plus x into dv by dx equals to s square plus v square s square by 2x into vx. And the right hand side becomes 1 plus v square by 2v. Because numerator is also s square, denominator is also a term s square. So cancelling s square, the right hand side is 1 plus v square by 2v. Then you have to find x into dv by dx. X into dv by dx is 1 plus v square by 2v minus v. Then you have to simplify it. 1 plus v square minus 2v square by 2v, which will becomes 1 minus v square by 2v. Then you use the rule variable separation. Variable separation means you have to take all the term of v to dv and all x term to dx. Then which will becomes 2v dv by 1 minus v square equals to dx by x. By separation method, by variable separation, this denominator becomes the numerator of the left hand side and here the numerator becomes the denominator of the right hand side. And then you separate the term v and x. Now we have to integrate both sides. Integrating both sides, simple integration. If we take 1 minus v square as t, then the derivative is minus 2v dv. So we have to multiply minus on both sides. That is minus 2v dv by 1 minus v square equals to minus dx by x. Then we now integrate both sides. Integration becomes log 1 minus v square, because if it is the term t, then its numerator is its derivative. Then integration of dt by t is log t, means log 1 minus v square. Just you take 1 minus v square as t minus 2v dv as dt. So we have multiply minus on both sides to integrate easily. Then the integration of left hand side is log 1 minus v square equals to minus log x. If both are integration associated with logarithm, then you take constant as log c. Then which will becomes 1 minus v square into x. If we take minus log x to left hand side, the left hand side becomes log 1 minus b square plus log x. That will be log a plus log b. That is log ab. Then deleting logarithm on both sides, we have 1 minus b square into x is equals to c. Now you have to put v as y by x. If y is equal to vx, then v is equal to y by x. Now we have to put, instead of v square as 1 minus y square by s square into x is equal to c. Then after simplification, which will becomes s square minus y square is equal to cx. That is the general solution of this differential equation. First you have to identify whether the equation is homogeneous or not. If the equation is homogeneous, then you have to put y is equal to vx. Then by separation method you can solve, and lastly you have to put the value of v as y by x. Then you will get the general solution. Another example which can easily solved by the variables homogeneous method. Suppose the differential equation is of the form y square plus s square into dy by dx equals to xy into dy by dx. This is also a homogeneous differential equation because its each term is same degree term. Here the power of y is 2, here is also power of x is 2, and here the power of x and y both is 2. 1, 1, 2. So it is a homogeneous differential equation. If the each term are same degree, then it is easily you can identify it is a homogeneous differential equation. Then you have to find dy by dx. Taking dy by dx common, the left hand side becomes s square minus xy, which is equal to minus y square. Then dy by dx equals to y square by xy minus s square. First you have to find dy by dx. Now put y equals to vx. That is the general procedure to find the solution of a differential equation. You have to just put y equal to vx. Then dy by dx equals to v plus x into dv by dx. Derivative of vx by product rule, the right hand side becomes v plus x into dv by dx. Now the equation becomes v plus x into dv by dx equals to v square s square by x into vx minus s square. Now the right hand side numerator is also s square, denominator is also s square. Taking common and cancelling, we have the right hand side is v square by v minus 1. Then you have to find x into dv by dx, which will gives v square by v minus 1 minus v. Then after simplification, the right hand side becomes v square minus v square plus v by v minus 1. Then the numerator cancelling v square and minus v square, the right hand side becomes v by v minus 1. Now we have to separation method. That is v minus 1 by v dv equals to dx by x. Now we have to integrate both sides, which will becomes 1 minus 1 by v dv equals to dx by x. V by v is 1 and minus 1 by v. Integrating both sides, we have integration of 1 is v minus integration of dv by v is log v equals to log x plus log c. Now instead of v we can write log e to the power v. It is easy to delete the logarithm on both sides. Instead of v we can write log e to the power v. minus log v equals to log cx. Log a plus log b equals to log ab, which is equal to e to the power v by v equals to cx. Log a minus log b is equal to log a by b. Then deleting logarithm on both sides, we have e to the power v by v equals to cx. That means e to the power v equals to cxv. Now we have to put v as y by x, which will becomes e to the power y by x equals to cx into y by x. Cancelling x, we have e to the power y by x equals to cy. This is the solution of this differential equation. Very easy method. First you have to identify whether the differential equation is homogeneous or not. If it is homogeneous, then you find dy by dx. Then you put y is equal to vx. Then derivative of y is equal to vx. Then we write dy by dx as v plus x into dv by dx. Then after simplification, we will get two variable. One is function of v, another is function of x. Then you take the method of variable separation to integrate both sides. And after the integration is over, you just put v as y by x. Then you will get the general solution of the homogeneous differential equation. This differential equation, to solve, how to solve the homogeneous differential equation, it is easily, and go through some more examples which can clarify your idea. Next we have to discuss about the some special form. Special form of the homogeneous differential equation. If the differential equation is of the form dy by dx equals to a1x plus b1y plus c1 by a2x plus b2y plus c2. This differential equation is not homogeneous because here the constant term is c1, here is also c2. So this differential equation is not homogeneous. We have to make it homogeneous. There are two methods, case 1 and case 2. Case 1 and case 2. More important, this type of differential equation is more important. Here, if a1 by a2 is not equal to b1 by b2, one type. Another type is if a1 by a2 equals to b1 by b2. I shall give you two examples which can clarify to solve this type of non-homogeneous equation. This is the special form of the homogeneous equation. One is dy by dx. If the dy by dx is a1x plus b1y plus c1 by a2x plus b2y plus c2, then first you have to look at whether a1 by a2 equals to b1 by b2 or a1 by a2 is not equal to b1 by b2. Then there are two different methods to solve this type of differential equation. I shall give two examples for these two cases which will clarify your idea. Then you can solve the homogeneous differential equation, and it's also some special form. Suppose the differential equation is of the form dy by dx equals to y minus x plus 1 by y plus x plus 5. Suppose the differential equation is of the form dy by dx equals to y minus x plus 1 by y plus x plus 5. This type of differential equation you can easily identify because this is a equation of straight line. So it is not homogeneous because here contain a constant term 1, here is also 5. So it is not homogeneous. We have to make it homogeneous. Here a1 is minus 1, a2 is 1. The coefficient of x, here is minus 1, here is 1. b1 is 1 and b2 is also 1. a1 by a2 is not equal to b1 by b2. So, in which method we can convert this equation to homogeneous? In this type of equation, you put small x as capital X plus h and small y as capital Y plus k. This is the method to convert this non-homogeneous equation to homogeneous. Then we have to solve in homogeneous method. First, check whether a1 by a2 is equal to b1 by b2 or a1 by a2 is not equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, just you put small x as capital X plus h and small y is equal to capital Y plus k. This is the general method. Then small dx equals to capital Dx, because h and k are constant. Small dy is equal to capital Dy. Now the differential equation 1 becomes capital dy by dx equals to, instead of y you put y plus k minus x minus h plus 1 by capital Y plus k plus x plus h plus 5. You put small y as y plus k and small x as x plus h. Then the numerator becomes y minus x plus k minus h plus 1 divided by y plus x plus k plus h plus 5. Our aim to convert this non-homogeneous equation to homogeneous. When the differential equation becomes homogeneous, there will be no constant term. So you take k minus h plus 1 as 0, k plus h plus 5 is equal to 0. And solving this equation, you have to find the value of h and k. Adding these two, we have 2k plus 6 equals to 0. Means k equals to minus 3. K equals to minus 3. Then minus 3 plus h plus 5 equals to 0. This implies h is equal to minus 2. First you have to find the value of h and k. So for the value of h is minus 2 and k is minus 3, this equation becomes homogeneous. Now the differential equation becomes dy by dx as y minus x by y plus x, because we take these two terms as 0. We have to make the equation as homogeneous. Now this equation is a homogeneous differential equation. We have to solve in homogeneous method. Put y as capital Y as v capital X, not small x. Take as capital X and capital Y. Then dy by dx equals to v plus x into dv by dx. Capital X and capital Y. Now the differential equation becomes v plus x into dv by dx equals to vx minus x by vx plus x. Take it is y2. Now the equation 2 becomes, instead of dy by dx, we write as v plus x into dv by dx, and the right hand side of the equation becomes vx minus x by vx plus x. Now the cancelling the term x in numerator and denominator, the right hand side becomes v minus 1 by v plus 1. Now vx into dv by dx equals to v minus 1 by v plus 1 minus v. Then after simplification, it will be v minus 1 minus v square minus v by v plus 1. That will becomes, cancelling v, we have minus of 1 plus v square by 1 plus v. Taking minus common from numerator, the right hand side becomes 1 plus v square by 1 plus v. Now using the variable separation, 1 plus v by 1 plus v by 1 plus v square dv equals to minus dx by x, which will becomes dv by 1 plus v square plus v dv by 1 plus v square equals to minus dx by x. Now we have to integrate both sides. Integrating both sides, here 1 plus v square is taking t, then its derivative is 2v dv. But here it is v dv. Then we have to multiply 2 and also divide 2 there. Then after integration, the left hand side becomes tan inverse v. Integration of dv by 1 plus v square is tan inverse v. Here it will be half log 1 plus v square, because we have to multiply 2 in the numerator, also divide 2 there. Then the denominator, if we take the denominator as t, then its derivative is 2v. That is, here we have to multiply 2, also divide 2. That is dt by t, its integration is log 1 plus v square, log t. And the right hand side becomes minus log x plus log c. Now we have to delete logarithm on both sides. Then the general solution is e to the power tan inverse v, e to the power tan inverse v plus into 1 plus v square root over equals to c by x. Here it is minus log x plus c, that will be log c by x, that will become c by x. Now the solution becomes e to the power tan inverse v means capital Y by capital X, not small y by small x, because we take as y equals to vx, and it will be 1 plus y square by s square square root into x equals to c. Then after simplification it becomes e to the power tan inverse y by x into s square plus y square square root equals to c. Here the denominator is a term of x, here is also x. Cancelling this, we will get e to the power tan inverse y by x into s square plus y square root over equal to c. This is not the general solution. Then we have to convert capital and capital X. That will be e to the power tan inverse. Instead of y, we have to take y minus k. K is here minus 3. So that will be y plus 3 by x plus 2. You have to put here the value of h and k. Then you have to replace capital and capital Y in terms of small x and small y. So here capital Y is y minus k, capital X is x minus h. Now putting the value of h and k here, we have y is y plus 3 and capital X h small x plus 2 into s square means x plus 2 whole square plus y plus 3 whole square root equals to c. This is the general solution of this particular differential equation, which is not homogeneous. We have to make it homogeneous. If a1 by 2 is not equal to b1 by b2, then you take small x as x plus h and small y is y plus k. If you go through more examples, then you will get a clear idea to solve this type of questions. I shall give you another examples. Suppose the differential equation is of the form 4x plus 6y plus 5 into dx minus 2x plus 3y plus 4 into dy equals to 0. Now first you find just dy by dx. Here dy by dx is 4x plus 6y plus 5 by 2x plus 3y plus 4. This is not a homogeneous differential equation because the numerator contains a constant term, denominator is also a constant term. So it is not homogeneous. Then we have to check whether a1 by 2 is equal to b1 by b2 or a1 by 2 is not equal to b1 by b2. Here a1 by a2, a1 is 4, a2 is 2, 4 by 2 is 2. Also b1 by b2, 6 by 3 is also 2. So this is a case of a1 by a2 is equals to b1 by b2. Then how you can solve this type of equation? If a1 by a2 is not equal to b1 by b2, then you take small x as capital X plus h and small y as capital Y plus k. But it is a case where a1 by a2 is equal to b1 by b2. In this case, you take 2x plus 3y as z. 2x plus 3y as z, because if it is z, then it will becomes 2z. So simply you take the lowest value as z, 2x plus 3y as z. Then differentiating 2 plus 3 into dy by dx equals to dz by dx. This implies 3 into dy by dx equals to dz by dx minus 2. Then dy by dx equals to dz by dx minus 2 divided by 3. Now, instead of dy by dx, you just write dz by dx minus 2 by 3. Then the right hand side becomes 2z plus 5 by z plus 4. Because we take 2x plus 3y as z, so it is z plus 4, but the numerator becomes 2z plus 5. Because it is the 2 times, numerator is 2 times the denominator. So that is 2z plus 5 by z plus 4. This implies dz by dx equals to 2 plus 6z plus 15 by z plus 4. You multiply 3 here, that will be 6z plus 15, and minus 2 to the taking to right hand side, it will be plus 2. So right hand side becomes 2 plus 6z plus 15 by z plus 4. Then after simplification, it will be 2z plus 8 plus 6z plus 15 by z plus 4. Then the numerator becomes 8z plus 23 by z plus 4. Now we have to separate z and x term. Then the differential equation becomes z plus 4 by 8z plus 23 into dz equals to dx. Just you separate z and dz and dx. Now we have to integrate both sides. This is a improper fraction because the polynomial in the numerator and the polynomial in the denominator are same degree. So it is a improper rational function. We have to equalize the coefficients. Then you multiply 8 here. It will be 8z plus 32 by 8z plus 23 equals to 8 dx. We multiply 8 on both sides. Sorry, here it will be dz. Now dz plus 23 plus 9 by 8z plus 23 into dz equals to dx. Now dividing this, we will get dz plus 9 dz by 8z plus 23 equals to 8 dx. Now we can easily integrate it. Integrating both sides, we have integration of z as dz as z. Here the integration will be 9 by 8 log 8z plus 23 equals to 8x plus c. Because if we take as t, then it is 8 dz. So you have to multiply 8 here, also divide here. So that will be 9 by 8. Now you just put z as 2x plus 3. Here we take z as 2x plus 3. So the general solution becomes 2x plus 3y plus 9 by 8 log 8z means 16x plus 24y plus 23 equals to 8x plus c. Then the left hand side becomes 3y plus 3y minus 6x. 3y minus 6x plus 9 by 8 log 16x plus 24y plus 23 equals to c. Or after simplification it will be 24y minus 48x plus 9 log 16x plus 24y plus 23 equals to 8c or c1. This is the general solution. You can also cancelling 3 here also. Maybe or may not be, this is the general solution of this differential equation. Very important article and the last article of this differential equation. All the unit 4 is complete. Integration and definite integration and differential equation, these are all completed. So this is the most important article for the plus 2 students, also for the point of examination. So you just try and solve it carefully. Thank you all. Again, thank you to everyone